Hi folks, welcome back. In this video, we'll do some benchmarking on the NAS that I have built. With a 4-port SATA card added, now have a capacity to add about 6 drives in there. But for the benchmarking purposes, I'll be just adding 4 drives. 2 of those drives will be on the IO card and 2 of the drives will be connected to the motherboard directly. And we'll be running all our benchmarking tests using that setup. And once we get basic numbers, I'll go ahead and complete the build with all 6 drives in the NAS unit.
Alright folks, so here I am. I've turned on my NAS again, and now I attached 2 more drives to the IOCrest IO card. And the problem that I ran into was, when you look at this, I can see the 4 drives here, but there's no way I can figure out which 2 drives are connected to the IO card and which 2 are connected directly to the motherboard chipset. So what I had to do was I did create these, and I assumed that the ADA0 and 1 are the motherboard, are connected to the motherboard, and 2 and 3 are connected to the IO card. But apparently that was not the case. So what has happened is I have labeled these wrong. This volume is going to be the AMD APU volume, because the disks in these volume are actually connected to the APU. So what I'm going to do is I'll just go ahead, delete these volumes, recreate them again.
I'll be running 5 benchmarks. So out of the 5, 4 of them will be a combination of mirrored volumes and striped volumes on both the IOCrest controller and the AMD APU controller. And the 5th one, I'll be connecting 4 drives to the IOCrest controller and setting up a RAID Z ZFS array and benchmarking that. Now I'll go ahead and create the volume on the AMD APU controller. While the datasets are being created, let me find a file that is large enough for us to benchmark this NAS with. Now I have a few video files that are about 4 GB, but they are all residing on my spindle drives, and ideally I would want something on my SSD to test these with. This will essentially copy these 2 files into one big file.dat. In the meantime, while that is being copied, I'll create 2 CIFS shares on the 2 datasets that we have created earlier. I'll enable write permissions on both the shares for group and others. By default, LG4 compression will be enabled on the volumes that we create, but for benchmarking purposes, we would be disabling those to test the raw throughput of the volumes. We have these 2 shares accessible from Windows now. Now there we have the 8 GB file that we have created by combining 2 4 GB files together. We'll create a new folder in the share and then start copying the file over using robocopy. Now the copying is almost complete, and here we see we get a throughput of about 5328.62 megabytes per minute. So let's just divide that by 60, and that translates to about 88.8 megabytes per second. Not bad. Now at this point, after we are done with one benchmark, it's just rinse and repeat for all the other type of benchmarks. And I'll be doing a whole bunch of deleting the volumes, recreating them, recreating the shares, recopying the files over, reading the files as well from the NAS to my local drive, and over again till we get all the numbers. While I was benchmarking, during one of the tests, while I was reading data from the NAS onto my hard disk, I could hear clicking noises from the NAS, and at that point I knew that one of the drive was failing. So I just had to replace one of the drives and rerun the test again.
The issue that I'm running into with this disk, I didn't check this before, but the disk already has a GPT partition table or GUID partition table, and now when I try to do a wipe on this disk, FreeNAS gives me an error saying that it cannot wipe the drive because it can see a GPT on there. So to get around this, what I'm going to do is I'm just going to go to the shell and overwrite the partition table with 512 bytes, so the first sector on the drive with zeros. And basically what that would do is that would mean that FreeNAS would see the disk as empty or unformatted, and then it'll easily wipe itself. So to do that, this, I'll issue this command. Once that is done, I should be able to successfully wipe the disk.
And now once that is done, it's back to our same business of rinsing and repeating, creating a share, copying files, and keeping track of the benchmark numbers. So after a long time, after a whole bunch of read-write tests and doing the same thing over and over again, these are the final benchmark numbers. I'm pretty impressed with these numbers, especially considering it's just a $200 hardware. So after adding the IOCrest controller card, which is about $35 to $39 depending on where you buy it, the total build cost is now about $180, still below the $200 price point. I'll go ahead and update the spec sheets to include the controller card in there as well. Now, one thing I failed to mention in this whole video is we are using a regular DDR3 RAM and not the ECC RAM. The problem of using a regular DDR3 RAM in such NAS builds is that if there is memory corruption on the DDR chip, there is no way for the NAS to detect it. And if that memory contains data that is to be returned to the disks, now the data that is written to the disk will be corrupted as well, and that is a big problem for NAS. But for this NAS, I won't be storing a much of valuable data, and I definitely have multiple backups of this as well. I know I might regret the statement later, but for now I'm fine with the risks that I'm taking by using DDR3 RAM. If I were to use an ECC RAM, what would happen is if there were any bit corruptions in the memory, the system would just shut down and it won't propagate the corrupted data onto the disk, thereby saving the data. Now, if I want to use an ECC RAM, I'll have to go with a different board and of course a different memory, and that would easily add about $200 to this RAM build. In the future, I may do it, but at this point, I think I'm pretty content with what I have. That is it, folks. Until next time, have a good day.